What about a covalent bond? We're going to make this bond between a carbon atom and a hydrogen atom. But first, let's consider the carbon atom. It has a filled first shell that has no role whatsoever in creating this new bond. We need to look at the outer shell. In this case, the outer shell is the second shell. And counting them up, we have 4 valence electrons. So, to meet the octet rule, we must either lose 4 electrons to achieve 0 electrons in the outer shell, or gain 4 electrons to achieve 8 electrons in the outer shell. An alternative method to show this is C for carbon, then the use of a dot to represent a valence electron. Thus, there are 4 dots around the letter C. Okay, now let's consider the hydrogen atom. It's different from the carbon atom because now the outer shell is the first shell. We have 1 valence electron. So to gain an electron will result in 2 electrons in the outer shell to meet the octet rule and gain stability. We depict this as H for hydrogen and an X representing a valence electron. You don't have to associate X always with hydrogen valence electrons, nor the dot with carbon valence electrons. But we want different symbols with different atoms so we can see where the electrons originally came from. How do we meet the octet rule for each atom? 1 carbon and 1 hydrogen won't do it. 1 hydrogen offers 1 electron, but the carbon needs 4 electrons for stability. So we require 1 carbon and 4 hydrogens, where each electron from each hydrogen is involved and is shared with the carbon. The carbon has 4 electrons to share with 4 hydrogen atoms. The act of sharing electrons creates a covalent bond, and we can depict this as an X and a dot next to each other to show the pair of electrons involved. This is called a Lewis structure, and if we look at it, we can see that each hydrogen has shared its electron with the carbon, and the carbon outer shell has gone from 4 to 8 valence electrons, and now it's gained extra stability through the octet rule. Let's now think about the carbon that has shared its electron with each hydrogen. So each hydrogen's outer shell has 1 electron that was originally with hydrogen and another electron that is shared with the carbon. Thus, each hydrogen atom has a filled outer shell of 2 electrons. Another method to depict this is called the Kekule structure. Instead of having a dot and an X to represent the bond, we display the 2 electrons that make up the bond as a line.